Hello, this is Sudha Malli, Assistant Professor, Department of Civil Engineering from Rohini College of Engineering and Technology, Kanyakumari. Today we learn about the total station, especially for electronic distance measurement, parts of a total station. So, in electronic distance measurement, it's an accurate distance measurement was the most difficult of the surveying operation. The introduction of electromagnetic distance measurement has completely removed this difficulty. It is a method of determining the length between 2 points using electromagnetic waves, infrared and microwaves, and etc. Microwave records transmitters, receivers, and both ends. Infrared use as a transmitter at one end and a reflecting prism at the other end. Most commonly used. EDM is commonly carried out with the digital instruments called theolites. Electronic theolites displays horizontal vertical angles to 0.1 second with a standard deviation of 0.5 seconds. Then working principles of EDM. It's very useful in measuring distance that was difficult to access and or long distances. It measures the time required by a wave to be sent to a target and reflect back. All the equipments are based on the principle that the distance is equal to the velocity into time. Basically, there are two methods. First one is pulsed laser method. Second one is phase shift method. In this method is mostly commonly used. Pulsed laser method. It is essentially based on the simple concept that the distance is a product of velocity and time. Make uses pulses derived from an infrared or visible laser diode. Distance is obtained by measuring transit time and velocity of pulsed electromagnetic signal in traveling between TS and target and back. Velocity v of pulses get determined. Transit time is measured using electronic signal processing techniques. Therefore, distance d is equal to 0.5 into v into t. V means velocity, t is the time. Large number of pulses gets analyzed during measurements. So, in second one, phase difference method. Speed of light is in vacuum is well known, but the measurements are taken not in vacuum. Thus, corrections for atmospheric conditions are to be made. Further, because of great speed of light, it is not possible to directly and precisely measure the time taken for the travel. In order to overcome this problem, EDM instruments measure the phase difference between the transmitted and received signals. For this, light beams of different wavelengths are used to determine the distance. This forms the basis for the pulse difference method. Majority of EDM instruments, whether infrared or microwave, adopt this form of measurement. The principle of EDM is presented. Uses continuous EM waves, measures length by directly determine the number of full and partial cycles of transmitted EM between the two ends of a line. EDMI, that means electronic distance measuring instrument consisting of an electrowave generator, an oscillator, a modulator, transmitter, and a receiver, etc. Modulated EM wave is transmitted to the target placed at the other end of the line. The target, acting as a reflector, reflects the light beam back to the receiver, where the incoming light is converted to an electrical signal. A phase comparison is made between the projected and reflected signals. Then the amount by which the transmitted and received signals are out of phase gets measured electronically and get registered in a meter by getting converted to an equivalent distances. So, phase difference method. if the received signal is out of phase by the measure of del theta, then the equivalent distance d is equal to del theta into lambda divided by 360. So lambda is wavelength of the EM wave. The distance is calculated as d is equal to 1 by 2 into n number of times into lambda plus del theta divided by 360 into lambda. N is the integral number of wavelength, lambda is the double path. So this is the phase difference method diagram. Then one is total station. As discussed earlier, total stations are capable of measuring angles and distances and combine an electronic theodolite with the distance measuring system and a microprocessors. So then total station is an electronic optical instrument. Electronic theodolite having optical telescope integrated with the EDM, that means the electronic distance meter, and microprocessors with memory unit and other accessories. It consists of keyboard, display, power supply, data collectors, field computers, memory card, and etc. Provides by measuring or estimating all parameters, that means distance and angles and derived values, corrections and coordinates of surveying record. Values of parameters can get displayed in viewing panel. Precision may vary from 0.1 second to 20 seconds. So types of total station. Based on minimum circle reading accuracy 0.1 second to 20 second. For example, 1 second total station, 2 second total station, 5 second, 15 second, 20 second, and etc. Based on control, it's a manual, robotic, then semi-automatic total station, automatic total station, servo-driven total stations, and etc. Operator controls from distance via remote mode. So manual total station means this type of total stations are the oldest ones. In this type, it is necessary to read the horizontal and vertical angles manually. The only value that could be read electronically was the slope distance. Semi-automatically total station means in this type, the total station, the horizontal circle had to be read manually and the vertical circle readings were shown digitally. Slope distance were measured electronically, including the reduction of values of horizontal and vertical components. Automatic total station means in this type, total station which is in use nowadays. These instruments function electronically and sense both horizontal and vertical angles, measure slope, distance and the components, and determine the coordinates of observed points. So parts of total station. The total station comprises an EDM theodolite enhanced input microprocessor. For storing the data, a memory card is also provided. It consists of a battery that is provided in the battery socket. The typical total station consists of the following components. That means handle screw, data input or output terminal, instrument height mark, battery cover, operational panel, tri-badge, then shifting clamp, base plate, leveling foot screw, circular lever adjusting screws, circular level, display, objectives lens, and tabular compass slot, then optical plummet focusing ring, optical plummet rectifier cover, then optical plummet eyepiece, then horizontal clamp, horizontal fine motion screw, data input and output connector, external power source connector, plate level adjusting screws, vertical clamp, vertical fine motion screw, telescope eyepiece, telescope focusing ring, peep sight, instrument center mark, and keyboard. The keyboard is an essential accessory record for giving the command to the microprocessor inbuilt in the total station, as it contains various keys. Such keys include common keys, switching keys, lighting keys, power keys, and etc. The different types of keys incorporated in the keyboard with their functions have been listed as follows. Power key. It is to switch on or off the total station. Star key to switch from one mode to another mode and to change settings of the total station. Then illuminator key, it's to use to turn on or off the laser pointer and the guiding light to light the reticle, as well as to select the screen backlight's brightness, and etc. is to return the previous screen or cancel the input data. Tab key to switch to another item. Then base key to delete an item on the left side. Then special key to input to blank space. Then functional key to switch between the observations. Then end key, select or accept any input value or observations. Shift key, it may used to switch between lowercase and uppercase characters. Then target keys, it's used to switch between the different targets. Then data collectors, memory cards, reflectors, softwares. These are the most of the total stations the operating system used in Windows. Then okay, thank you.